morning. In this video, we are going to talk about proposition 28 from book 1. Okay, so this proposition declares that if a straight line falling on two other straight lines, and if an exterior angle is equal to the opposite interior angle, and then those two straight lines are parallel, or if the two interior angle, the sum of them on the same side, is equal to two right angles, then these two straight lines are parallel. So it can be divided into two scenarios. And let's take this picture as an example. So, and this is alpha, and this is beta. So it says this is an exterior angle if an exterior angle is equal to an opposite interior angle, then they are parallel. Let's make it L1 and L2. Or it says if interior angles from the same side, they have the sum equal to two right angles, then they are parallel. Let's give them a proof one by one, okay? So scenario 1, please recall, let me see, proposition 15, vertical angles are equal. So it means that this angle must be equal to this. Right? They are vertical angles because the straight line here, EF, is meeting another straight line CD at the point of H. So we use proposition 15. We know that alpha is equal to alpha prime, right? And recall proposition 27. If the alternative angles are equal, then two lines are parallel. So we see that alpha prime and beta are two alternative angles. They are equal because we know that alpha equals to beta, and we can apply common notion one. If two things are equal to the same, then they are equal. So we know that alpha prime equals to beta. So which means two lines are parallel because of proposition 27. Okay, this is the proof of scenario 1. And in terms of scenario 2, let's say we know that these two angles, they have the sum of two right angles, and we also know that alpha prime and theta, the sum of them are also equals to two right angles because of proposition 13. We prove that if two straight lines meets with each other, then the sum of two adjacent angles are equal to two right angles. So these are two adjacent angles of the meeting straight lines EF and CD, right? So the sum of them must be equal to two right angles, right? And let us apply postulate 4. All right angles are equal. So the right side of these two equalities are equal. And then apply common notion 1 again. We can conclude that we can conclude this equality. And if we use common notion 3, if two things are equal, then we subtract the same thing from both sides. The results are equal. So let us subtract angle theta from this equality. Then we have beta equals to alpha prime, right? And pay attention to proposition 27 again. They are two alternative angles. So if they are equal, then we prove that L1 is parallel to L2, and this is the end of scenario 2. So if we combine them together, we can prove our proposition 28. That is the end of this video, and in the next one we are going to talk about proposition 29. Thanks for watching. Have a good day.